Okay, today we're going to go over derivatives of common functions, and what this is really going to be is a list of formulas for derivatives. Okay, you know what the derivative means, right? If I write down f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h, right? That's the derivative. But you don't always have to work it out in detail like this, because a lot of formulas, the derivatives are actually very, very easy. For instance, let me just give you a quick example. If I wrote f of x equals 7x squared plus 3x plus 2, I can almost instantly tell you the derivative. It's 14x plus 3. Okay? Because I know a shortcut for it. And that's what I'm going to teach you today. Several shortcuts for derivatives so that you don't have to do this limit every time. Okay? All right, so let's get started. The first thing we're going to do is the derivative of a constant function. So, suppose f of x equals c, okay, where c is a constant. Let's find the derivative. F prime of x would equal the limit of f of x plus c minus, f of x plus h minus f of x over h as h approaches 0. But because f of x equals a constant, c, then that means on the top we just have c minus c, which is of course 0, right? All right, and what's 0 divided by h? Remember, h is not 0. H is going to approach 0. Okay, but that doesn't mean that it ever equals 0. So what I have there is 0 over some number that's not 0. Well, what do you get when you divide 0 by something? You get 0, right? So this is just the limit of 0, which is, of course, 0. So there you go. The derivative of a constant function is always 0. Okay, let's write that down here. I'm going to write derivatives of common functions. Okay, and we have our first one here, the derivative of a constant. Now, it doesn't make any sense really for me to write c prime, so I'm going to use the other symbol, the d over dx one. Okay, so that's the derivative of a constant, and that equals 0. Okay. All right, number 2. I want to show you how to do the derivative of x raised to some power. Okay, now I'm going to tell you the rule for this, the formula, and this formula is true for any real number n. Okay? I can't prove that for you now. You need to learn a lot more first. In fact, we don't finish proving that until Calc 2. So what I'm going to do is, just so that you can see how it works, Okay, I'm going to prove it for you when n is a non-negative integer. Okay, but the formula is true for any real number n. All right, so first let's do what happens if n equals 0. So suppose f of x equals x to the 0. And I'll put in parentheses, and x is not 0. Because 0 to the 0 is oftentimes considered to be undefined. Okay? All right, well, this one actually we've already done, because what is a number raised to the power 0? It's 1, right? So if f of x equals x to the 0, then f of x equals a constant. So we've already said f prime of x would be 0. Okay? So let's leave that there for a minute. Okay, now let's do this. Suppose f of x equals x to the n for some positive integer n, so some positive whole number. Okay? All right, then let's look at the derivative. So we would have f prime of x equals the limit of f of x plus h minus f of x over h as h goes to 0. Okay? And in this case, what would that equal? In this case, that would equal the limit of x plus h to the n minus x to the n over h. All right, now, this part right here might be very, very complicated to work out. It all depends upon how big is the number n. Okay, if that's like a 10 or an 11 or something, then this would be really lengthy to figure out. There is a theorem called the Binomial Theorem that you might know that tells us a formula for it. But the important thing is, all I need to do is we only need to write down part of this. Okay, so again, I'm just looking at this part right here. Okay, I can tell you that that is always going to start out with an x to the n. Okay, and then the next term is always going to be n times x to the power n minus 1 times h. And then the next term will be something we don't even need to worry about what that number will be. Okay, and it's going to be x to the n minus 2 times h squared. And it continues like that. The power of the x goes down by 1, and the power of the h goes up by 1. If you need an example, just always remember this one. X plus h squared, what would that equal? That equals x squared plus 2xh plus h squared. Okay? For x plus h cubed, that equals x cubed plus 3x squared h plus 3x xh squared plus h cubed. Okay? That's all I'm doing here is, you see there's a formula for these types of things. And it always starts with x to the power n. And then the second term is always n times x to the power 1 less times h. And then the next term is always a number times x to the power 1 less times h to the power 1 more. And it just keeps going like that, okay, every single time. That's all I'm writing down over here on the right. Okay? All right, now this continues, and eventually you get to the end, and at the end you're always going to have h to the power n. Okay? So that thing right there is always going to come out looking like this. Okay? Now what else do we have? We have minus x to the n, and that is all over h. Okay? What do you notice? The x to the n's will cancel. And everything in the middle has an h, which will cancel out with this h down here. Okay? And this is what we'll be left with. We'll be left with the limit as h goes to 0. Okay? The x to the n's have canceled. And there's not going to be an h on the bottom anymore because it's going to cancel out with an h from every term on the top. Which means that this right here, after you cancel out the h, is just going to be n times x to the n minus 1, and the h will cancel. Okay. And then in the next term, right here, we have some number times x to the n minus 2 times h to the power, now it will be just to the power 1, because one of the two h's canceled out with the h on the bottom. Okay, and then it continues as we go, and then when we get to the end here, now instead of h to the n, it will be h to the n minus 1, because one of the n's canceled, one of the h's canceled out with the h on the bottom. Okay, now let h go to 0, and what do you notice? This will disappear, all of this stuff here disappears, all of that disappears. The only thing that doesn't disappear is this thing, because there's no h. And so that's going to be what we end up with. N to the power x to the n minus 1. That's the derivative of x to the n. Okay, so let's go up and write that down there for number 2. The derivative of x to the n equals n to the power, not n to the power, n times x to the power n minus 1. So here's a way that I often remember it. You take the exponent and you put it down in front, and then you subtract 1 from the exponent. Okay? All right. Now, at this point, what I would like to do is we are going to add to that list some more, but I want to start a second list here, which we are going to call rules of derivatives, or let's call it differentiation rules. Okay, number one is going to be called the sum and difference rule. Okay, and what I want to show you is how to work out the derivative of, let's do the sum first of two functions, if those two functions are differentiable. Okay, so let's write this up here at the top. Let's write, let f and g be differentiable. Remember, that means that they have a derivative. Okay, so let's work out then, would f plus g have a derivative? Well, let's see. Let's just write it down and see. So you can write it like this. You can write the derivative of f plus g. That's one way of writing it. Or another way of writing it is to write f plus g prime of x. Okay, it doesn't matter. They mean the same thing. The important thing is let's figure out what it actually is going to equal. Okay, so again, I'm just going to write it equals the limit of f of x plus h plus g of x plus h minus f of x plus g of x over h, as h goes to 0. Now, by just rearranging things, notice that I could rewrite that like this. F of x plus h minus f of x plus g of x plus h minus g of x over h. And I can break that up into this limit plus this limit because both of these limits exist, because f and g are differentiable. And the first limit is called what? It's called f prime of x. And what's the second limit called? It's called g prime of x. So in other words, the derivative of f plus g equals the derivative of f plus the derivative of g. Okay? And that same thing would have worked if it was minus. The only difference is these two pluses would have been minuses, which means this plus in the middle here would have been a minus, and that would carry down. So the derivative of f of x minus g of x is the derivative of f minus the derivative of g. Okay, and that's called the sum difference rule. The derivative of f plus or minus, let's say, we can do them at the same time, equals the derivative of f plus or minus the derivative of g. Okay, so that's a very important rule to remember. Okay, and the second important rule that I want to show you is called the constant multiple rule. And that says, what if you have a function like f of x, and then you multiply that function times a constant, and then you want to find the derivative of that. What would it equal? Okay, so again, let's just work it out because it's actually pretty easy to see what that would equal. All you have to do is write it down and see what you get. Okay, so what would that be? It would be the limit. You should be getting very used to this by now. The limit of c times f of x plus h minus c times f of x, and that is over h. Well, look, I can just factor the c out. Because both terms on top have that c. And I can even factor that all the way out of the limit. So now just ask yourself, what have we been left with? We've just been left with c times what? F prime of x. Because that's what this is right here, is f prime of x. Okay, so the derivative of a constant times f equals that constant times f prime. Okay, and now I can show you how I did that example at the beginning of the lecture. Is it still written up there? Let's see. No, I had erased it. So I'm just going to make a new one here. Okay, let me shrink this down so we can see all of these rules that we've done so far. And then over on the side in red, I'll write a new function. I think I remember the other one, wasn't it 7x squared plus 3x plus 2 or something very similar to that? Let's just go with that. And really quickly I told you that the derivative was 14x plus 3. How did I get that so fast? Well, I used these 4 rules. That's exactly what I did. And here's how I did it. Let's look first at the x squared. What's the derivative of x squared? Well, using this rule, the derivative of x squared would be 2 times x to the power 1, right? So then what's the derivative of 7x squared? Using this rule, I would multiply the derivative of x squared times 7. And that's where I got the 14x from. Okay? Then we had plus 3x. Okay, then we had plus 3x. So using this rule, then the derivative will have a plus. And then what's the derivative of 3x? Well, using this rule, the derivative of x is 1. Do you see that? Because it will be 1 times x to the power 0. And 1 times x to the power 0 is 1, right? And then using this rule, the derivative of 3x would be 3 times 1. Okay, and then we have a plus 2. So using this rule, we get a plus, and then using this rule, the derivative of the constant 2 is 0. So you see we ended up with 14x plus 3 plus 0. That's where I get the 14x from. The takeaway here that I want you to understand is that you can get the derivative of any polynomial very, very fast. Let's do another one. Okay, what if we had 5x cubed plus 8x squared plus 4x minus 7. Okay, now I'm going to show you how to even speed up the process a little bit. Okay. Using this rule and this rule together, here's what you can do. For the 5x cubed, you take the 3 down, and you're going to get a 3 in front, but there's already a 5 in front. So you end up with 3 times 5, and what is that? 15. And then you subtract 1 from that 3, and you end up with x squared. Okay? Let's do the same thing for the next term. The 2 comes down, but there's already an 8, and so we end up with 2 times 8, which is 16. And you subtract 1 from that exponent, and we have the new power is 2 minus 1, which is 1. And so we end up with 16x. Okay? And then for the next one, for 4x, it's not really showing there, but that's really 4x to the power 1, right? We take that 1 down, hits the 4, we get 1 times 4, which is 4. Subtract 1 from that exponent, you have x to the power 0, which is just 1. And so we just have 4 times 1, which is 4. And the last one is a constant, and so its derivative is 0, and so it doesn't contribute anything to the derivative. So there we have 5x cubed plus 8x squared plus 4x minus 7. The derivative is 15x squared plus 16x plus 4. Okay, I'll do one more with you. Let's do 12x to the 10th plus 9x to the 5th plus x to the 3rd plus 8. Okay, I'll give you a second to work out the derivative. Go ahead and do that now. Okay, did you get it? Let's see what it should be. We should get 12 times 10 is 120, and then it'll be x to the 9th plus 5 times 9, that will be 45, and we'll get x to the 4th plus 3x to the 2 plus nothing, right? And there's our derivative. 120x to the 9th plus 45x to the 4th plus 3x squared. Okay, so the derivatives of polynomials should now be very, very easy for you to do. All right, let's continue. I have some more shortcuts to show you. These next two I'm not going to prove for you because we're going to talk about these functions a lot more in Calculus 2. But I know you've seen these functions, and the functions I'm talking about are e to the x and natural log of x. I know that you've seen them in pre-calculus or college algebra. We're going to deal with them more in depth in Calc 2, but they will come up sometimes in problems. in exercises, okay, and in Calc 1. So let me just go ahead and tell you for now, and we'll prove it next semester. The derivative of e to the x is e to the x. It's actually a very famous function because it's its own derivative, which is a very strange situation. Okay, and the derivative of the natural log of x equals 1 over x. So we won't prove that until Calc 2, but you can go ahead and use those formulas anytime you need to. Okay. Next, what I want to show you is called the product rule. And it is probably not what you would expect. So I want to show you how to do the derivative of f of x times g of x. It's different than the constant multiple rule, which was a function times a number. Now here we're doing a function times another function. You would probably expect it to equal this, f prime times g prime, but it is absolutely not equal to that. It is equal to something more complicated. Okay, so let me show you what it equals. All right. Let's start by doing what we've always been doing, which is to just write down what it should be. It should be the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x over h. Okay? Now, in order to simplify that, I'm going to do a little trick here that is probably not something that would occur to you, when that's okay, because it's out of left field. It's going to look like I'm making things more complicated, but you'll see that that allows me to actually make them simpler. So what I'm going to do is I'm going to throw in here an extra minus f of x plus h times g of x. But I can't just go changing things, right? So I need to also cancel that back out again. And then let's not forget that there was more to start with. There was, at the end, a minus f of x times g of x. So what I've just done, just so that you notice, is I've added this stuff in the middle. But I haven't actually changed the problem because I added and subtracted the same thing, which means I've actually added 0. Why would I do that? Why would I put something in and take it right back out again? Well, here's the reason why. Because now I can split this up as two separate fractions, with this stuff on top of the first fraction and this stuff on top of the second fraction. Okay? So there's the first one. And here's the second one. Okay, and I can now split that up into two separate limits. Okay, and also in the first one there, notice on the top that both terms have an f of x plus h, so I can factor that out. Let's look at the second big fraction. Both terms have a g of x, so I can factor that out. And I'm going to choose, just because I like the way it looks better, I'm going to put that g of x at the end instead of the beginning. Okay, and now let's do the limits. What's the limit of this as h goes to 0? It will just be f of x, right? What's the limit of this as h goes to 0? That's the thing that we call g prime of x. What's the limit of this as h goes to 0? That's the thing that we call f prime of x. And then this one here doesn't even have an h in it, so there's no limit to worry about for that last one. And there we go. Now, I personally, well, me and everybody I know, we prefer to swap these things. Swap those two and write it like this. F prime times g plus f times g prime. That's how people usually write it. Some people say f prime times g plus g prime times f. Of course, that would be the same thing, right? So that's called the product rule. It's not what you would expect, but it's very important and you need to memorize it. The derivative of f times g is the derivative of f times g plus f times the derivative of g. Very important. Okay, now what about quotients? What about the derivative of f of x over g of x? This is called the quotient rule. Oh, I forgot to write the name of that last one, so let me do that. Here, let me fix this. There you go. Number 3 is called the product rule. And this one, number 4, is going to be called the quotient rule. It takes a little bit longer to show you, but just be patient and stick with me. It's not difficult. It just takes some writing. Okay. So let's write down the limit of f of x plus h over g of x plus h minus f of x over g of x over h. And let's see how we can manipulate that and get it to work out to something that we can recognize. Okay? So the first thing I will do is I'll rewrite it like this. Instead of having fractions in fractions, let's rewrite it like this. That guy minus this guy times 1 over h. Okay? The limit of that whole thing. And the next thing I think we should do that would make sense is let's go ahead and do this subtraction right there, which means they need a common denominator, right? And what would the common denominator be? It would be the first denominator times the second denominator. And then on top, the f of x plus h is going to pick up a g of x, and the f of x is going to pick up a g of x plus h, because that's how it works when you subtract fractions, right? Okay, and now I'm going to do something very similar to what we did for the product rule. I'm going to add in something extra and then turn around and take it right back away again for the purpose of, so that I can split it up into two fractions. Two particular fractions. That will make it easier. Okay, so here's what I'm going to add in and take back away again. It's f of x times g of x. So I want to write in the middle, I want to write minus f of x times g of x, and then turn around and write plus f of x times g of x. Okay, and then there's the minus f of x times g of x plus h. Okay, and all of that is over g of x plus h times g of x. And then that whole thing is being multiplied times 1 over h. And there we go. Okay, now, how can I break that up into a way that will be helpful? So here's what I can do. I'm going to write two fractions. They're both going to have g of x plus h on the bottom times g of x. Okay. And on the top of the first one, we'll have this. And on the top of the second one, we'll have this. Okay, the only problem is just trying to squeeze it in there. All right, now we're getting somewhere. Watch what we can do. Okay, in that first fraction, do you see that on the top, both terms have a g of x? So I can factor that out. And what will that do? It will cancel out with the g of x on the bottom. Do you see that? Both terms on the top have a g of x, and I can factor that out, and then it will cancel out with the g of x on the bottom. So here's what I will end up with. F of x plus h minus f of x over g of x plus h. Okay? And then what's the second one have in common on the top? Both terms have an f of x. So I can factor that out. Now it will not cancel out because there is no f of x on the bottom. So nothing's going to cancel, but it's still worthwhile to factor that f of x out. It might look like things will cancel out here with these g's, but look closely and you'll see that they don't. Okay, and now just a couple of more little manipulations here, and then we'll see a formula. So here's what I'm going to do. We need to multiply times 1 over h. So what's that going to do? It's going to put an h on the bottom of both fractions, correct? So here's what we're going to get at the beginning. We're going to have an f of x plus h minus f of x. Okay, and then under that, we're going to have an h times g of x plus h. Okay, and then we're going to have plus f of x, and now what I would like to do here, let me just copy down what I have. So look at the top. Oh, and now there's an h under there too. So look at the top. See how it's g of x minus g of x plus h? Okay. You can switch the order of a subtraction, right, if it changes the sign. And so here's what I'm going to do. I'm going to change that plus in the middle to a minus, and then that will allow me to change the order on the top, because I think you will recognize this order a bit better. Okay, almost done. I told you this one takes a bit longer, but if you just stick with me, it'll all come out nicely here in just a couple minutes. Okay, so let's do this. I think you will recognize this. I think you'll recognize that. And then we have that. Okay, that's from here. Does that make sense to you? And then we have a minus. And then let's write f of x and then let's write the fraction g of x plus h minus g of x over h, and then another fraction with g of x plus h and g of x on the bottom. Okay. Now the algebra is done and we can do the limit. What's the limit of this? You should recognize that. That's the thing that we call f prime. What's the limit of this? That's going to be 1 over g of x, right? So let's just put a g of x under there. And then our minus sign in the middle. And then there's an f of x times, what's the limit of that? That's the thing that we call g prime. Times, what's the limit of this? Won't that just be 1 over g of x times g of x? In other words, 1 over g of x squared. Well, that looks a lot better. And we can make it even better than that if I just multiply this first fraction times g of x over g of x, then look at what we have. F prime times g over g squared minus f times g prime over g squared. And that's what we call the quotient rule. Took a while to get there, but now we have a nice formula. Okay, let's go up and write it down. The derivative of f over g equals f prime times g minus f times g prime divided by g squared, as long as g of x isn't 0. That's called the quotient rule. Okay, so you have 4 very important rules now that can help you to do derivatives much faster. The sum and product rule, sum and difference rule, constant multiple rule, the product rule, and the quotient rule. And you also have a few derivatives of very common functions. And I'm going to give you 2 more, but let me look at the time here. We're already at 52 minutes, so I won't prove these last 2 today. We'll do it some other time. But let me at least write them down for you today. I would like to show you the derivative of sine and cosine. Okay, the derivative of sine is cosine, and the derivative of cosine is negative sine. We'll prove those later, but at least now you have them so you can use them when you need to. Okay, so that which is on the screen right now, these are very, very, oh, there's even more. Let me shrink it down. These are very, very helpful formulas. You can call them shortcuts if you want. They will allow you to find tons and tons of derivatives now without having to do the whole limit as h goes to 0. Let's just finish off by doing one example just so you can see. Let me show you how I can do the derivative of this really quickly. Let's say 5x squared plus 2x plus 1 over 3x minus 2. Let's find that derivative really quickly, just using these rules that I have on here. Okay, so it's a quotient, right? So I'll use the quotient rule. So I'll do the derivative of the top, which is 10x plus 2, times the bottom, which is 3x minus 2, minus the top times the derivative of the bottom, which is a 3, divided by the bottom squared. And now it's just a matter of algebra. Let's just work that out. So we're going to have 30x squared minus 14x minus 4 minus 15x squared plus 6x plus 3 over 9x squared minus 12x plus 4. So that is 15x squared minus 20x minus 7 over 9x squared minus 12x plus 4. There we go. That was pretty fast. Try doing that same problem by using the limit as h goes to 0. It would take you a very, very long time. And we just use a lot of rules there. Obviously, we used the quotient rule. That's obvious, I think. But we also used the sum and difference rule and the constant multiple rule and the derivative of a constant function and the derivative of x to the n. So we really just use 5 of those rules. And you can use these shortcuts on your homeworks now. Okay, unless it asks you to specifically use the limit definition, which the current homework assignment does. But on the next homework assignment, it'll just say find the derivatives, and it won't tell you how to do it, which means you can do it using these shortcuts. All right, that's it for today.